We're starting chapter 2 section 1 and we are solving inequalities. So all our equations we've been working on in the last chapter had equal signs in them. This particular case we're going to have something like a greater than or an equal sign, and that's where the inequalities are coming into play. So it's time to start looking at inequalities today, and we're going to take a slight variation on that multiplication property. The multiplication property, as you recall, says something of the effect that if A was equal to B, you could multiply both sides by C and it stays the same. When we have inequalities, it changes a little bit. So let's take a look at that multiplication property for inequalities. When A is less than B, and what's very important here is whether C is a positive number or a negative number. If C is positive, then we can multiply both sides of the inequality by C, and the order does not change. If it started as a less than, it's going to stay a less than. If it started as a greater than, it's going to stay as a greater than. But the difference, to compare and contrast, is here on the second part of this multiplication property. If A is less than B and we're multiplying by a negative number, the direction of the inequality changes. So if C is a negative number, it goes from a less than to a greater than, or it goes from a greater than to a less than. And the same thing is true for division. If A is less than B and we're dividing by C, a positive number, it stays the same. The inequality, if it starts a less than, stays a less than, starts a greater than, stays a greater than. But if we divide by a negative number, then that changes the inequality from a less than to a greater than, or a greater than to a less than. So to summarize it, anytime we multiply or divide by a negative number, it changes the inequality. And I kind of summarize it in a little statement that if you multiply or divide by a negative number, you're changing the plus or minus sign. That's also going to change the inequality sign. So I summarize that: if you're going to change the sign, change the sign. So we need to change the sign both times. All right, let's start out with looking at a few examples. We've seen these before in Algebra 1. 7x plus 23 is less than 2. Pretty simple, pretty straightforward. We're going to start out by subtracting 23 from both sides. We need to get the 7x by itself by undoing the addition of 23. So 7x is less than negative 21. So we ask the question, how do we solve for x? Well, we solve for x by dividing by 7. It's a positive 7. So whether it's multiplication by a positive number, division by a positive number, we don't have to worry about anything. It doesn't matter, the constant is negative. What matters is what we're going to divide by, or multiply by. And we're dividing by a positive 7 here. So to divide by a positive 7, 7x divided by 7 is x. Negative 21 divided by 7 is negative 3. We don't have to change the inequality because we're dividing by a positive number. It's only when we multiply or divide by a negative number. Now, when we're doing inequalities, it's sometimes, in fact, a lot of times, it's very helpful to take its picture. That's my paraphrase for saying we should graph it. I know you've done this in Algebra 1. It might have been a while. When we have a less than sign without a greater than sign, we don't want to include the actual point, negative 3 itself. So on our number line, we're going to put an open circle around negative 3 to signify everything up to negative 3, but not including negative 3. If there was an equal sign, less than or equal, we would shade in the negative 3 to include it, but it's not there. All right, so in this case, where do we find things smaller than negative 3? Well, on the number line, smaller than negative 3 is to the left. So I want to shade in everything to the left of negative 3, make my arrow really large and dark and obvious. That means that that pattern goes in that direction forever and ever. So that's solving inequalities, looking at their graphs. We're going to do a few more of those today. So let's take a look at the next one. We've got some simplifying to do first. We need to distribute the 4 to the 2 minus x, and then try to get the x's together and simplify and see what our answer is. So let's get started on that. Distributing, 4 times 2 is 8. 4 times negative x is negative 4x. That's all we did in that first step. Next step, we want to get all the x's together. Usually, students like to see x on the left side of the equal sign. The symmetric property says it really doesn't matter. But since most of us are used to seeing the x on the left side, let's do that. So to do that, we're going to add x to the right side because that will eliminate that negative x. But whatever we do to one side, we have to add it to the other side as well. So when we add x to both sides, that's going to give me 8 minus 3x is less than 6. Now we want to get the negative 3x by itself, get all the constants together. So let's subtract 8 from both sides, and that's negative 3x is less than negative 2. Now here's where we have to start being careful. To get x by itself, I need to divide by a negative 3. And we divide by a negative. It changes the direction of the inequality. So when you have an inequality, anytime you multiply or divide by a negative number, which we are, negative 3, it changes the less than to a greater than, or a greater than to the less than. All right, we need to take its picture or graph it. X is greater than 2/3. Somewhere we will estimate where 2/3 is, put a dot there and label it so we know that's 2/3. There's no equal sign, it's greater, so we're going to put an open circle around it, meaning up to 2/3 but not including it. And numbers greater than 2/3 on the number line are to the right. So that's graphing our second inequality. All right, we've got a few more to look at. 8x greater than 4 distributed to 1 plus 2x. So let's start out by distributing. 4 times 1 is 4. 4 times 2x is plus 8x. And an interesting thing is going to happen here, so watch very closely and carefully. We would like to get all the x's together, probably on the left side. So I look to see what x is on the right side. There's a plus 8x. To undo addition, to undo addition, I'm going to subtract 8x from both sides. But a strange thing happens. 8x minus 8x is 0. On the left, on the right, 8x minus 8x drops out and leaves me with the 4. So here's something you need to keep looking at because all year long we're going to run into this. When you're solving an equation, or in today's example, an inequality, when all the variables drop out, that's going to happen sometimes. So the question is, what do you do when that happens? Well, here's what you do. You ask yourself, what's left? Is it a true statement or is it a false statement? So 0 greater than 4, true or false? That's false. When it's false, that means there's no solution. No possible solution if it's false. You could write that one of 3 ways. You could write the words no solution. You can write the 2 set symbols with nothing in between there, signifying the empty set. Or you can use that little 0 with a slash through it, meaning the null set. All 3 of them mean the same thing, no solution. All right, let's contrast that with this next example. Let's distribute out the 2. 2 times 5 is 10. 2 times 3x is 6x. Yep, I think we can see already. We're going to subtract 6x from both sides to try to get all the variables together on the left. But the same thing happens. All the variables drop out. So we need to ask ourselves this question as we look at what's left. Is 0 less than 10 a true statement or a false statement? In this case, it's a true statement. Whenever it's a true statement, that means your answer is all real numbers. That means everything works. There's a math shorthand for all real numbers if you don't want to write out the phrase. It's kind of like a scripted R. That means all real numbers. If you had to take the picture of all real numbers, you just draw in everything on the number line. Everything. The previous example for the null set, we just didn't draw a number line because there was nothing to draw on it. But for all real numbers, if you had to draw a number line, it's everything going forever to the left and going forever to the right. All right, so that's our first look today at solving inequalities.